Managing the Oracle Instance Part 2 of 2. In this nugget, we pick up where we left off in the previous nugget, this time first focusing on the Oracle 11g Automatic Diagnostic Repository, or ADR. Specifically in this nugget, we'll take a look at the alert log and learn to understand the messages that Oracle gives us regarding the running state of the instance and the database. We'll then focus on metadata, data about data, the two chief mechanisms for gaining insight into the Oracle database itself are number one, the collection of tables and views known as the data dictionary, and also a subset of the data dictionary that gives us dynamic information, in other words, data that changes over time. It's variable depending upon what's happening in the database. These views are called DPVs, or Dynamic Performance Views. Let's get to work. The book I'd like to recommend for you in this nugget is yet again another O'Reilly title. This one is called Oracle SQL Plus: The Definitive Guide by Jonathan Genick. Again, I've read this book from cover to cover, and I do want to say, just parenthetically to you, that I do not receive any kind of promotional consideration for suggesting these tech books and these websites to you. It'd be kind of nice if I did. But no, I'm simply, from one professional to another, offering you these books because I believe that they're high quality and can supplement the training that you're receiving from me in this nugget. Now then, you'll notice that I've called out the second edition. There's no third edition as of this recording in April 2011, so the closest you're going to get is coverage of Oracle Database 10G. However, I've found that Oracle doesn't change the SQL Plus utility all that much from version to version, so as long as you have the second edition, you should be great. By the time you finish reading this book and practicing through the examples, you will be a wizard with Oracle SQL Plus. Frankly, just by the end of this training, you'll have enough SQL Plus expertise to certainly pass your exams, but in the real world, you'll need to really master this tool. Now then, what is the Oracle Alert Log? The Oracle Alert Log is an XML formatted file, extensible markup language. XML, you should immediately start thinking, cool, that's a general format that describes data and can be used to export and import into just about any system under the sun, and that's true. Specifically, this alert log is a chronological listing of messages and errors generated by Oracle Database. It's stored in what's called the Automatic Diagnostic Repository. We'll talk more about that in just a second. The default location, the file path for the ADR, is Oracle Base diag rdbms, and then under rdbms, the name of your database, then the SID of the database, trace, and then finally you have these alert_sid.log files created. That's a long path for sure. The good news is that you can just specify one initialization parameter for the ADR, and the alert logs will be written to this honkin' path transparently. Now, the kind of records you're looking for day-to-day as an Oracle database administrator consist of things like certainly error messages, and these are called ORA messages because all errors generated by Oracle database are prefixed with ORA dash and then some code. There are plenty of good websites out there that make their living, so to speak, by presenting you with a catalog of those Oracle error codes as well as descriptions of what they mean, and then most importantly, what remediative action we can take to resolve those errors when they crop up. Other records that exist in the Oracle alert log include initialization parameters that are at non-default settings. This is especially helpful if you want to troubleshoot a problem on a system that you don't own. If you're an Oracle consultant, you'll be walking into a fresh environment on servers that you may not have set up, so it's nice to see which initialization parameters are not at their default values so you can focus on those. Finally, Oracle Alert Log is useful for tracking administrative operations, including the special kind of SQL statements called Data Definition Language, or DDL statements. These are object creation statements like create, alter, and drop. Those have far-reaching consequences, so we tend to take a look at DDL with a very jaded, critical eye as Oracle DBAs. Alright, so you understand the purpose of the alert log. You know it's in XML format. It's stored in this place called the ADR. How do we get to the file to read it? After all, not many of us are interested in looking at the raw XML. You can do that if that floats your boat. But the good news is that Oracle Enterprise Manager has a really nice graphical interface interface to the alert log. It's fully searchable, and it parses and structures the raw XML elements and makes it a lot easier to look at. Again, you can open the XML in your favorite text editor or XML editor. You can even run select star from the dynamic performance view $diag info to pull those alert log records directly from the data dictionary. Besides the alert logs, we need to understand some things about trace files. Trace files are written by server processes and background processes. We know that server processes run on behalf of users as well as Oracle background processes. And what they do is report status over time. Environment information, activity information, error information. So therefore, this tracing, the ability to trace the behavior of server and background processes, is extremely helpful for us as DBAs when we're certainly troubleshooting problems, as well as doing performance tuning. We as database administrators should be fairly well obsessed on how to increase the efficiency, the running efficiency of our Oracle databases, and how to get them to run as quickly as possible, but at the same time as reliably as possible. Now, a little bit more about Automatic Diagnostic Repository, or ADR. This is defined by Oracle as a file-based repository for database diagnostic data, traces, dumps, the alert log, health monitor reports, all that kind of stuff. And the location for the ADR per server is specified using a single initialization parameter, and that is one you should know. It's diagnostic_dest. There are some deprecated parameters like background dump dest and user dump dest. We don't want to use those anymore. We specify ADR with a single init param. I like how Oracle gradually simplifies these things, similarly to how we talked about automatic memory management and having all of your auto memory handled with a single initialization parameter. So in sum, ADR provides a centralized storage location for alerts and traces, and the fact that the ADR uses a known file spec or a file path, it's similar to optimal flexible architecture in terms of standardization. Let me jump back to the previous whiteboard for a moment, and you'll note that the default path for the ADR is under not Oracle Home, which is per database, but Oracle Base, which is the root of all installed instances on a particular server. So you have Oracle Base diag being the global home directory for all alerting, reporting, and tracing information on that server. So you could have multiple instances of Oracle Database, you could have Oracle HTTP server, Oracle Application Server, all this stuff running on a box, and all diagnostic information for all those Oracle products is stored in the ADR. It's very intelligent in my opinion. In this first demonstration, we'll look at alert logging and tracing in Oracle Database 11G. However, because I like to add as much value to my courses as possible, I first want to address this certificate error that I can almost guarantee you're going to see whenever you log into Oracle Enterprise Manager. You'll see an error that says something to the effect of, there is a problem with this certificate. Do you want to continue? And you have to continue in order to log into the website. And thereafter, at least in Internet Explorer 8 and 9, you'll have this prominent red address bar with a certificate error. Now, what is the problem here? The problem here, friends, is that Oracle Enterprise Manager by default ships with what's called a self-signed digital certificate. Because Internet Explorer 8 doesn't trust this self-signed certificate, it has a Trusted Root Certification Authority store where it stores globally known registrars like Thought, Entrust, VeriSign. And because this is a self-signed certificate that's trusted only by Oracle initially, Internet Explorer gives you this warning. Now, there are several workarounds if you don't want to see the certificate error anymore. A website you should be familiar with is stackoverflow.com. There's a whole collection of these overflow sites. There's serverfault.com for server administrators. Stack Overflow is primarily for developers. This is a community question and answer website. Definitely keep it in your browser bookmarks. Anyway, there's a Stack Overflow question and answer set called What Do I Need to Do to Get IE8 to Accept a Self-Signed Certificate? And you'll come across some really great answers, step-by-step instructions asking you to do things like view the certificate and then run the certificate import wizard to add the digital certificate to the Trusted Root certificate store. I'll add that right now. Click Next, Finish, and then ostensibly we can restart and not have any more certificate significant errors, but you'll read at Stack Overflow that's not always the case. Another thing you can do if you're really frustrated with this is unsecure Enterprise Manager. Instead of using secure HTTP, which is the default, we can run the Enterprise Manager control utility along with unsecure DB console. And what that will do is unbind SSL from the website, and from then on you'll have to access using HTTP instead of HTTPS. So those are just some preliminary thoughts to ponder. Now then, what about the alert log and the trace file in Oracle 11g? Well, first let's look at the easy way around. In Enterprise Manager, right on the front page, the database homepage, we can scroll down about halfway and see alerts that give us warning or critical states. You'll note that we can filter this table to look at everything, to look only at incidents or responses. And you'll notice we have several incidents here: access violation detected in, it looks like the log itself, and then the alert being triggered. The message is hyperlinked, as you'll notice, where it takes us to an incident status page that gives us a timeline of occurrences of this particular error, a specific problem key. This is going to serve as a unique identifier for the problem, timestamp, as well as recommended actions. It looks like there's no recommended actions in this case, but the Oracle Database Health Engine is normally very good at giving you remediation. Now, all of this specific metadata is going to be useful to share with Oracle support if you do need to file an incident with them. If we click View Problem Details, we get to a specific form that on the left gives us as much metadata as Oracle is able to give us, and on the right, Investigate and Resolve, a link to the Oracle support page. Quick Package is an excellent way to take all this metadata and wrap it up for transport to Oracle support. And note that there are links here to run assessment checkers. Isn't that great? Let's select the database link to come back to the home page. Again, we'll scroll down. And so that's how this alert log functionality works. You can also see the entire alert log by coming down a little bit farther. First, you see related alerts. You'll note that there's a disclosure triangle where you can show or hide those items on the home page. Depending upon which alert you're looking at, there may be related ones. Policy violations, critical rules violated, critical security patches, and a compliance score. We'll talk more about security policy later in the course, and we'll talk also about patching Oracle. And then under related links at the bottom, there are a couple alert log options. There's alert log contents and alert history. Let's click alert log contents. We're asked, first of all, how many entries do we want to see? I'm going to select last 100 and click go. The view alert log contents page gives us the name of the log location, which is the ADR location added with several subdirectories specific to our SID, the size of the file, and then there's our entries here. This is everything. Cool. Now, speaking of this log location, what does that look like? Let's pop out into the file system. Under CApp Oracle Diag RDBMS Oracle, you have two folders here that are relevant. There's alert that shows the alert log in its native XML format, or if we go to trace, the default location stores our trace files, which have the TRC extension, binary files. Alert Oracle log is the text representation of the alert log, so we can open it in Notepad or another text editor, and you'll see it's very plainly visible. It's easy to see. Gives us our non-default values, as previously discussed, startup of our background processes, checkpoint, SMON, etc., data file information, all that good stuff. Alrighty, so to finish up, let's log into SQL+. I'll log on as my currently logged on credential using the sysdba privilege, and the $V dynamic performance view that's of use to us in investigating the automatic diagnostic repository is called v$diaginfo. So first let me run describe, which is a SQL Plus command where we can take a look at the schema of a schema object. In other words, the structure of a schema object. We'll describe v$diaginfo, and you'll see that we have three columns here: instance ID, name, and value. Well, we have just a single instance on this server. Very simple table, so therefore we should be able to select splat or select everything. Splat, because this looks like a bug splat on a windshield, is also called the asterisk, and also is our SQL operator for retrieving all columns from a table or view. And sure enough, we get our columns back and our data, but it looks terrible, doesn't it? It just looks absolutely horrible. This is because we need to format our columns, doesn't it? So why don't I get those column names again? So why don't I use the column command, inst ID with format, and we'll do 5 for instance ID, We'll do a width of 20 for name. We'll see how that works. Sometimes there's guesswork in doing these on-the-fly column formats. It's just the way it is. For value, we'll format A20 as well. List to make sure we still have our query in the buffer, which we do, / to rerun. Now, if you don't make a column wide enough, you get hash marks, but I'm not so concerned about that for the simple reason that we have just a single instance on this server. Looks like we need to expand the value column just a little bit. So we'll run column value format A30. All right, that's about as good as we can get. Now let's take a look at this. The diaginfo $view tells us whether we have diagnostics enabled, which we do, and then it gives us the path for our automatic diagnostic repository. Note that there's an ADR base as well as an ADR home. By contrast to Oracle base and Oracle home, which do have environment variables, at least as of Oracle Database 11G, for whatever reason, we don't have environment variables, although you can create them for ADR base and ADR home. Find that interesting. That'll probably change in a future version of Oracle. The base is server-wide, I should say, and ADR home is specific per instance. There's our diagnostic trace location. There's our diagnostic alert location. So basically, this view, this $view, $diaginfo, is a great place to go just to verify that you have ADR up and running, that you have those names. I'm not going to call them environment variables, but the location of your ADR set where you know you're logging and tracing to. You can certainly change those locations if you want to. And then finally, you'll see at the tail end of the report, we have active problem count and active incident count, which we found on the home page of Enterprise Manager. There were 7 total records on that front page. Default trace file gives you the current trace file that's currently being written to. This is obviously going to change in time and harkens to the fact that this is dynamic information and therefore trapped in $diaginfo. Now about the data dictionary. We've discussed the data dictionary in a schematic, or as I sometimes describe as a flirtatious way thus far. Now let's really understand it from a formal standpoint. Data dictionary contains data about your database and instance. It's important that you understand where the data dictionary tables and views exist. They exist in a data file in the system and sysaux built-in table spaces. Data dictionary reference tables are read-only, so therefore they support only select, but even if you're logged in as the user sys who owns the data dictionary tables, you should not be interacting with those tables directly. Instead, you want to always access data dictionary using the views. Remember, views are virtual tables, in this case put together for us by Oracle. We don't want to corrupt or run the risk of damaging any of the data dictionary base tables. The types of metadata that are contained by data dictionary include, for instance, the definitions of every schema object in the database. So any objects created, period, no matter what they are, those SQL definitions are stored there, such that you can run the def command to run a define on any object, and you can get, for instance, if you put in a table, you can get a list of all the columns in the table, the nullability of those columns, the data type of those columns, etc. Data dictionary also tracks the amount of space allocated for those schema objects, constraint info per table, per column, all Oracle security information, the names of Oracle database users, all privileges and roles that have been granted to the users, as well as auditing, which is definitely taken a step up in the 11G release. Now, if you're coming from the SQL Server standpoint, you're thinking to yourself, well, this sounds a lot like the master database and a lot of those master system views. And that's true. I would draw a rough analogy to the master database in SQL Server if that helps you understand it a little bit more. Now, the 2 main types of data dictionary views are these guys, the ones that we talked about a little bit earlier that have the user, all, or DBA prefixes, and the other type are the dynamic performance views that all are aliased with the prefix $. That's why the DPVs are sometimes called $$ views. Now, as a review, the main data dictionary views, the ones that are prefixed, you'll remember that the user underscore views allow the currently logged on user to query metadata about objects that he or she created. The all underscore views give the currently logged on user access to all of the user stuff, as well as any other schema object database-wide to which that user has privilege. So it's a wider scope. DBA underscore views that are accessible only to, you guessed it, DBAs, allow full querying capability of the entire database, the entire data dictionary. Therefore, most of the time, we DBAs use the DBA underscore views. A special type of data dictionary table you should be familiar with is the dual table. This has a long history in Oracle. It's fairly interesting to look into. The origin of the word dual, for instance. It's kind of odd when it's first come across. Here's the setup, friends. The problem is Oracle SQL requires the from clause with select. And you might think, well, isn't that a no-brainer? How can I select rows from a table unless I specify the from clause? And that's true. That's absolutely true. But what if, for instance, you're wanting to run what's called a scalar function, in particular a system function like sysdate? If you come from SQL Server, you're familiar with selecting against built-in functions all day long. You don't have to specify a from clause. You could just do select sysdate and you get the current date and time that's set on that server's operating system. But because Oracle ANSI SQL is really strict, you need the from. So what we do with the dual table is we use it as kind of a dartboard. We use it as a virtual object to select against. You'll sometimes see something like sysdate or user as pseudo columns. So we could run select sysdate from dual to get the current date or time. We could run select user from dual to get the currently logged on user. Does that make sense? Now, if you run a define against the dual table, the schema is very simple. There's one column in it called dummy, varchar2, one character, and there's one value in that table, one row. Now, you don't want to do any operations on the dual table itself. Don't try to get funny and add additional rows or delete the built-in row. You simply want to use it for testing, for development, when you're running system or scalar functions. Scalar means that the function returns a single value, by the way. Now then, more about dynamic performance views, or $V views. I can draw the rough analogy between data dictionary views, you know, the user, all, and DBA views, and dynamic performance views that are part of the data dictionary in the following way. Think of, for instance, a vehicle's dashboard. You have the parts or components of that dashboard, things like the steering wheel, the glove compartment, the instrument panels. That denotes the metadata about that dashboard. That information, properties like number of steering wheels, 1, it's on the left side or the right side, the number of instrument panels, 3, etc. That kind of stuff is analogous to the data dictionary. It's fairly static information. However, if we look at a specific gauge on a vehicle's dashboard, let's say the speedometer, the value on that speedometer is going to change from moment to moment whether the vehicle's parked or in motion, right? So I would draw the analogy that the dials, the gauges on that instrument panel, are analogous to dynamic performance views. Dynamic performance views are virtual tables that store current live database activity. Now, the base tables in the data dictionary that map to your DPVs actually start with $V underscore dollar, but Oracle has given us synonyms or aliases for those tables to access the views as $V dollar something or other. Now, there's a lot of these $V dollar views. Some are more important and useful on a day-to-day basis than others. Oracle Enterprise Manager itself is a huge consumer of DPVs. You might have noticed just in browsing around Enterprise Manager the profusion, if you don't mind the $5 word, of all of those progress charts. You can look at system activity, you can look at hardware resource consumption. You're probably thinking, well, where does Oracle gather those metrics? It gathers those metrics by, in the background, querying these dynamic performance views. Gathering statistics, in other words. We'll be discussing Oracle statistics at a greater degree of depth later in this course. Some other info that can be culled or is culled from dynamic performance views include user session, server process information, locks, deadlocks, backup and restore status, status of files, data files, etc., as well as SQL execution plans. Anything related to numbers, you can pretty much rest assured that a dynamic performance view is tracking that information for you, and you can get to it through SQL or through Oracle Enterprise Manager. In this second demonstration, we'll work with the Oracle 11g database data dictionary and dynamic performance views. I've been playing around in SQL Plus here. I'm logged on as my currently logged on OS user with sysdba privilege. And let me type edit to show you what I have in the buffer. You'll remember that in order to set a default editor, we simply need to do set_editor equals and then the name of your preferred text editor. This first query I've been playing around with is I've been trying to get back the number of views per type in the data dictionary. An easy way to interact with the base tables of the data dictionary is to query from dict or dictionary. You can truncate or shorten a lot of these built-in names. It's an easy way to get to those tables. And I'm running the built-in system function count. If you do a count with star as the parameter, then it's going to grab all rows. And I'm filtering those rows by the column table name, like DBA. Like, of course, is the SQL pattern matcher, and we're going to bring back all objects that are prefixed with DBA. Now let me make sure to save what's in my buffer, do a /. So we have 705 DBA views. Wow. Let's edit again, and let's change this to user. Now, admittedly, I'm logged on as sys, effectively, so we should have quite a bit. 375, okay, and so on down the line. Let me do one more edit to get a number of all of our $$ views. Let me just edit the table name value, /, 600 $$ views. Now, that's a lot of views. I'll do host CLS to clear the screen, and now let's continue. If you run a description on dictionary, you'll see that they're just very simply, there's table name and then comments. The dual table, as I said before, is an easy way to run system functions in Oracle in an SQL environment and get around that from clause limitation. Let's do a describe on the dual table. And as I told you, there's just a single column called dummy, 1 character wide. If we do a select splat from dual, there's just a dummy value called X. All right. So similarly, if just want to draw this out a little bit, we can do a row count from dual. You know what to expect. It's going to be 1. You can select string literals, just to basically echo them on the screen from dual. You see, we can do, let me clear the screen again, stuff like that. We can select sysdate. This would be an example of a system function. And then finally select user from dual. I'm logged in as sys. By the way, we're going to cover this in a great degree of depth later when we do security in Oracle, but although I'm logged on as /, in other words, let me open my start menu, the Oracle operating system user, you notice that as far as Oracle is concerned, I'm logged on as sys. The reason for that, friends, is any Oracle user account, whether it's an OS account or from within Oracle itself that was created with the create user command, that's been given the sysdba privilege, effectively becomes the sys super user. So you want to be very careful as far as who belongs to the operating system DBA group, and you certainly want to be careful who you grant the sysdba privilege to, because they become sys. And sys is different from the system built-in sub-administrator account because sys owns the data dictionary and can devastate an entire system if a malicious user were to compromise the account. All right, so let's describe a typical data dictionary view. How about DBA_users? This one's a little bit more robust of a table, isn't it? You should understand these columns. They're pretty straightforward. Username, user ID, password, account status, lock date, whether the account's locked or not, etc. How about we run select username from DBA users, just to get a list. Quite a few. Normally, people who are new to Oracle are surprised when they see how many user accounts exist in an Oracle database, even without creating any on your own. In other words, let me take a quick look. All of these are system accounts that were created by Oracle, including the famous username Scott with a password of, do you know, Tiger. Therefore, if we create a user, I'll create one called Susan, identified by the password PASSWD. Don't worry about how we just did that. We'll talk more about and we'll learn how to create users later in the course. Let's now run select username from DB users. Again, actually, let's make that a little bit more granular, where username like S%. Boy, there's nothing like typos, right? Select username from DBA_users. As you see, the edit function is so helpful when you're working interactively. All right, so this gives us all our user accounts that start with S, and sure enough, Susan's in the list. I think you have the idea. Now let's answer some common DBA questions by consulting the data dictionary. How about finding out which users are able to log into the database? In other words, their account status status is open. Let's run select username and account underscore status, where account status. I like to use like because not often do you know exactly what the value is, right? So I'll just say open %. Forgot the from clause. Thank you, buffer. Appreciate it. / and then these accounts are open. By contrast, we can do exp. I happen to know that the exact value is expired or locked, but exp % allows us to not have to worry about the rest of that string. How about we answer the question, which data files and table spaces comprise the database? This is going to rely upon some dynamic performance views. I will actually bring up the editor to do this one. All right, in this one, we're querying two joined $v views, $v table space, and $v data file. I'm aliasing these so we don't have to type out $v table space or $v data file several times. We're aliasing table space to T and data file for D, and we're joining them on the TS column. Save the query, /, and here we get a nice report. It shows us our table space names, data files, and the size. We want to know, just as a way to wrap this up, where our control files are located. You know that we have the set parameter control file, right? We can also select splat from $v control file. Those are our two images. C and O, I've multiplexed them. Managing the Oracle Instance Part 2 of 2 review. In this nugget, we started off by looking at the alert log, what it is, why it's useful, how to query it, and where it's stored. You should also understand the basics of the Automatic Diagnostic Repository, ADR, and understand fully that context if you see any ADR or alert log related questions on your certification exam. We then gave a formal discussion of the data dictionary. From now on, you should be at least at the intermediate level with accessing data dictionary, understanding dynamic performance views, understanding the traditional DBA, all, and user data dictionary views, what they are, how they're used, and why they're used. I hope that this has been informative for you, and I'd like to thank you for viewing.